Hi, my name is Walter Nahara. I'm a student at California State University, Los Angeles, and these are week 6 of my notes for CS 4540. To begin with, let's have a scenario. So the user input a prompt, explain the moon landing to a 6-year-old in a few sentences. Two types of large language models, or LLMs, GPT-3 and Instruct GPT. When given the same prompt to both types, GPT-3 produces nonsensical responses where it lists off a series of unrelated questions that doesn't explicitly solve the answers. So right here in the image, we have four different questions that doesn't explain the moon landing. It tries to explain the theory of gravity, the theory of relativity, the Big Bang theory, and evolution, which all don't relate to the moon landing. Whereas with Instruct GPT, it explicitly states people went to the moon and they took pictures of what they saw and sent them back to the Earth so we can all see them, which perfectly explains the moon landing to a 6-year-old. We can say that GPT-3 doesn't follow user instructions, whereas Instruct GPT does manages to follow user instructions with very little issues. So how does one LLM manage to produce nonsensical responses, whereas another LLM is capable of following said instructions? Now, let's first discuss LLMs. So, large language models like ChatGPT are built through a complex pipelines that enables them to process and generate human-like text. And those three processes are pre-training, fine-tuning, and reinforcement learning. A typical case for LLMs involves tokens, which contains a small segment of the entire user input, ranging from text to images, which passes through a transformer, which encodes that segment's context and meaning before the model, using probability, guesses the next likely element to output until moving on to the next token. The results of programs utilizing LLMs are going to be different each time you run the same prompt, like how ChatGPT would produce different answers that, while meaning the same thing, are worded differently. Now, when it comes to these three different processes in LLMs, pre-training, fine-tuning, and reinforcement, before we go into detail, we should first introduce Andrej Karpathy. Who is he? Well, he born on October 23rd of 1986. He was actually one of the co-founder and worked at OpenAI, which is the company behind ChatGPT. He was a research scientist from 2015 to 2017, where he was poached by Elon Musk to work at Tesla, becoming their senior director of AI and leading the computer vision team of Tesla Autopilot from 2017 to 2022. He actually briefly returned to OpenAI from 2023 to 2024 to essentially just form a small team and improve upon GPT-4, which is the improved version of GPT-3 that we discussed earlier. In 2024, he started a new company called Eureka Labs, with its goal to improve the learning experience through AI. They're currently in development of their first project, which is the LLM 101N, designed for undergrad level classes within the realm of AI. One thing that I want to point out is that the following notes is taken from a video from his YouTube channel, as he has his own channel where he discusses topics relating to AI and LLMs. I also want to state that he also has his own website where he posts updates about his current project and discuss topics that he would normally explore in his videos on written form. Now, when it comes to the first phase, pre-training, the pre-training phase involves familiarizing the model with a large and diverse array of text data collected from the internet and equipping it with substantial knowledge. As the foundational phase, it allows the model to understand language, patterns, context, and concepts commonly encountered in human communication. Pre-training is only the first proper step, as the model at this point in the process is incapable of following user instructions nor producing proper answers, as we can see from GPT-3 from earlier, where it doesn't answer user instructions properly. This is where fine-tuning comes in. Fine-tuning refines the model's responses based on human curated interactions and desired behaviors. This stage in the process utilizes a specifically curated dataset of conversations and examples, which enables the model to improve its ability to respond accurately and appropriately to user prompts and questions. So you can think of pre-training as unloading a vast array of knowledge into the model, whereas fine-tuning ensures that the model understands context first and which type of information is appropriate given that context. Now, if we can look over at this picture here, the prompt that we have is why aren't birds real? And then if we look at the InstructGPT response, the model that went through the fine-tuning phase states, birds are not real because they are not made of flesh and blood. They are made of feathers, bones, and organs. Now, to you and me, this answer is completely wrong. Birds are real. The way that it's worded seems right, but we all know that it's wrong. This is what we refer to as hallucinations. Hallucination in the context of LLMs refers to when the model produces information that is inaccurate or fabricated despite sounding plausible. This occurs due to the reliance of statistical patterns rather than factual accuracy, leading to confident but false statements in their generated text. So if we remember that LMS are essentially built off of transformers, and transformers are built with billions upon billions of different parameters, which dictates the probability of which words comes next. This is why supervision is critical in order to stomp out the possibility of the model producing these hallucinations, ensuring that the outputs are accurate and reliable. When it comes to supervision, there are techniques that involve interrogating the model to determine its knowledge and boundaries and adjusting training. They include interrogation, which is generating questions and answers based on known facts, validation, comparing model responses to correct answers to identify knowledge gaps, and training adjustments, incorporate examples where the correct response is "I don't know" from unknown facts. Reinforcement learning is when we facilitate deeper reasoning by allowing models to explore various solutions and learn from successes and failures. That way, by assessing the outcomes of various approaches, the model learns to refine its method, thereby improving its reasoning and performance in tasks that require higher cognitive processing. Now, LMS actually implement a different type of reinforcement learning called reinforcement learning from human feedback, or RLHF. The implementation of RLHF signifies a shift in enhancing LMS capabilities, moving away from solely imitating human outputs to fostering intelligent reasoning processes. RLHF trains models using human feedback to improve performance in creating an unverifiable task. For unverifiable domains such as writing, RLHF trains a reward model to simulate human preferences, allowing RL to be applied without extensive human evaluation. Now, the benefits of RLHF includes human input, easier and more efficient than generating ideal responses. Model improvement allows models to learn from human preferences and scalability, which enables RL in domains where direct human evaluation is impractical. Now, there are some limitations when it comes to reinforcement learning from human feedback, which includes simulation limitations, where the reward model may not fully capture human preferences. In some cases, adversarial examples where the model can be gamed, leading to nonsensical results, and training constraints, where the training must be capped to prevent exploitation of the reward function. It's also important to point out that while it improves model performance, models can still hallucinate, making it crucial for human supervision to ensure accurate and reliable answers. One last topic to discuss is multimodal. It's relatively known that LLMs are reaching their limitation in terms of efficient application and capabilities, leading to questions of whether to continue forward with new methods to improve upon LLMs or abandon LLMs altogether for better methods. Now, one future advancement of LLMs include the implementation of multimodal capabilities, also referred to as multimodal LLMs. Multimodal LNS refers to the ability of LNS to process and generate information from multiple types of data modalities, allowing them to perform complex tasks that were incapable on single modality MLS. Now, here are the references. First off, we have the 3 hour long video from Andre Kabathi that goes over what we discussed in the previous slides. We also have a link to his website where you can look at other resources that he written and recorded for. And then we have OpenAI's article titled Aligning Language Models to Follow Instructions. This is where we actually got the examples for hallucinations and the differences between GPT-3 and their own LLM models, Instruct GPT. This is the end of my video. Thank you for watching and have a good day.